Hello, this is our lecture on isotopes. So, as we talked about in our last lecture on atomic structure, all elements are made up of protons, electrons, and neutrons. And atoms at a neutral charge have a set number of electrons and protons that make that atom a specific element. So, for example, a chlorine atom, if a chlorine atom somehow lost a proton, so normally chlorine atoms have 17 protons, its atomic number is 17. If it lost a proton somehow, it would no longer be considered chlorine and would now be considered a sulfur atom. Because chlorine has 17 protons. If it lost one, it would have 16, which would now make it a sulfur atom because sulfur's atomic number is 16. And if an atom changed its number of electrons, it would no longer be neutral because if it lost or gained an electron, it would now become an ion of a positive or a negative charge. But the same elements can have atoms that differ in their number of neutrons. So atoms that have the same number of protons but different number of neutrons are called isotopes. So, as an example, here are two isotopes of hydrogen. You have H1 and you have H2. This, with like the dash in the middle, is how we write isotopes, like how we keep them apart. And the number H1 and H2 indicate the atomic mass. So, if you look here, H1 has one proton and no neutrons, and H2 has one proton and one neutron. So that means that their mass number, 1 plus 0 is 1, which is how we get H1, and 1 plus 1 is 2, which is how we get H2. Here, you can see it also written in atomic notation, like we saw before. So you can calculate the number of neutrons that each one has in atomic notation, because we know that the number of neutrons is equal to the mass number, which is the top number, minus the number of protons, or the atomic number, which is the second number. So it gives you the same information if it's written like this or if it's written like this. Just as another example, here are three different versions of carbon isotopes. You have carbon 12, which has 6 protons and 6 neutrons, which give us 12. We have carbon 13, which has 6 protons and 7 neutrons, which gives us 13. And you have carbon 14, which has 6 protons and 8 neutrons, which gives us 14. Some isotopes are very happy to stay that way forever. Those isotopes are what we call stable isotopes. So, just as we talked about before, carbon 12 and carbon 13 are very stable. They're very happy to just stay the way that they are and have either 6 or 7 6 or 7 isotopes respectively. Sorry, not isotopes, 6 or 7 neutrons respectively. Other isotopes have too many neutrons in their nucleus, which causes them to be very unstable. They want to become stable as much as possible, which we know, I'm sure you've heard before. Atoms are always trying to become stable. And so they lose energy and subatomic particles in a process we call radioactive decay. These unstable isotopes are called radioisotopes. So for an example, carbon 14 is very unstable, and over time it will decay in a process we call beta particle decay, and it will lose a proton, so that it becomes nitrogen 14 instead of carbon 14, where it then is stable. Yeah, so that is our lecture. We got isotopes. The main thing is they differ in their number of neutrons, but they have the same amount of protons and they have the same amount of electrons. And then they can be stable, which we call stable isotopes, and they can be radioactive, which are unstable, and those are called radioisotopes.